Good evening, everyone. So, welcome to my second or third or fourth, I'm really not sure, class on process synchronization. So, today we're going to talk about what is the meaning of synchronization, what are the problems that synchronization will solve, and then we'll also see what solutions are there when we talk about synchronization. So, in today's class, we will be talking about mm, uh, not all of them, but of course, we'll be talking about the introduction, a little bit of what synchronization is and what are different kinds of synchronization, what is principles of concurrency, then a few terms that are related and we must know before we dive into this subject matter is race around conditions, mutual exclusion, precedence graph. What do you mean by critical section problem? And in my next video, because this it'll be very long, so I was thinking I'd keep it really short because if the video tends to be a little long, I've noticed that people will tend to lose interest. So I'm keeping it very short. And the software, hardware, and semaphores, the last three topics, we'll be covering it in the next video, which of course will be tomorrow. So let's just begin with understanding why synchronization is important for processes. So this is the topic of the topic name. The topic's name is process synchronization, and what are the various synchronization methods that are available to us, which we will talk about tomorrow. And so let's begin. So operating system supports multiprogramming. All modern operating system supports multiprogramming. So we must begin our class with the term multiprogramming. We've already done this before. We've got to revisit this. Until unless we don't understand this, we cannot go forward with synchronization. So where operating systems, or those operating systems that support multiprogramming, it means it allows many processes to execute concurrently in a system. So if you've got a system and many processes can run at the same time, that means it's multiprogramming. And that system can have a single processor, or that system can have a multiprocessor. So even in single processor, you can have concurrent processes. Processes can be executed at the same time. Many processes can start at the same time, but each process will, only one process will have that single processor. If you're talking about single processor system, so in a system that has only single processes, then many processes can execute concurrently, but at any given time the processor will be with only one processor. So somehow you get this feeling that all the processes are being executed even though the processor is with only one process. So but this switch is happening so fast that all the processors feel that they have the CPU, and as a user you feel everything is going at simultaneously. So it is not really going parallelly, it is interleaved. So when it is interleaved, we call that pseudo parallelism. It is not fully parallel. So if you've got many processes, and if you've got many processes, so all the processes are given to multiple processes, that is called true parallelism. So nonetheless, so multiprogramming बनेगा क्यों? When many processes are running concurrently, whether it's a single processor or whether it's with a multiple processor. Now we've seen this when there are many processes if you can bring many processes in the memory. So all of these processes are ready, and they need one or the other resource. Some may be requiring CPU, some may be requiring printer, some may be requiring certain memory, some files. So all of these resources, all of these files need. So all the processes that are executing are brought into the operating system. So when there are one or more processes in the RAM, when one or more processes are brought into the RAM for concurrent execution, it is called multiprogramming. You can see on the right, the first program A is running. It is with the CPU, and as soon as the program A waits, it has to do some input output. Then the CPU is not going to wait. It's going to pick up another program B, and program B is going to run. So because both of these program A and B are stored in the memory, then if you combine them, it looks something like this. So A has the CPU, and again B has the CPU. So the CPU is always busy, and then is program C can be here, D can be here, and again A, B will follow. So one or the other process will keep on running. In order to do that, we need multiprogramming. For multiprogramming, all the processes must reside in the main memory. Now multiprogramming can be achieved by a single processor or a multiprocessor system. If it is achieved by a single processor system, it is somewhat pseudo-parallel. It's not exactly parallel processing, it is interleaved processing. In a multiprocessor system, it's true parallelism. So we know now that when there are multiple programs in the memory, then it is called multiprogramming. Now when you do multiprogramming, so many processes are in the memory, like here many processes are in the memory. Now these processes, this job 1, job 2, job n, these processes, some processes may require that they communicate with each other, or some processes may be such that they may not require any communication with other processes. So in that case, processes that are concurrently in the memory, in a multi-programming scenario, when there are many processes in the memory and all of them are being concurrently executed, so all of these, some of the processes may be independent, they do not want to talk to each other, they don't have to talk to each other in order to finish their work, or there may be programs or processes in the memory that need to talk to each other. They are called cooperative. Cooperative means communicating, they need to communicate. And all these processes, all these concurrent processes in the memory, whether they are independent, they don't need to talk to each other, or they are cooperative, they need to talk to each other. They may be kind of executed concurrently or parallelly. This is what the diagram is showing. Now the important point to take away is that thupro processes memory man, they are all executing at the same time. Some processes are independent, fine. So independent processes भनेको एउटा, if one process is executing, it does not affect another process. So say there are two processes, P1 and P2. If P1 is executing, no matter what it executes, it does not affect P2. Now on the other hand, cooperating processes, if there are cooperating processes in the memory, so there are lots of processes in the memory, all of them running concurrently, and if they are cooperating with each other, then in that case, execution of one process affects the execution of another process. So एउटा प्रोसेस कस्तो पाराले एक्जिक्युट हुँदैछ त्यसको रिजल्टले अर्को प्रोसेसलाई इफेक्ट गर्छ in case of cooperative processes. So cooperative processes are also known as communicating processes. So in a memory, when there are lots of processes concurrently being executed at the same time, some processes may want to talk to each other, some processes may not want to talk to each other. Those processes that do not talk to each other are called independent processes. And so if job 1 is independent, if job 2 is independent, then the execution of job 1 will not affect execution of job 2. And the manner in which job 1 is executed will affect job 2, and the manner in which job 2 is executed will. Now this is a very crucial point for synchronization. Okay, then let's come to see now we are only talking about this problem arises when people start talking to each other. If it is independent processing, not much problem. There isn't much to look after, but want to talk to each other, and especially when one can affect the other, then there are problems. So we'll look into it a little more detail. So when communicating processes are there, when a process needs to communicate with another process, it is called interprocess communication. Now this is a small I may have covered. If I have not covered, I will send you the video, but we'll just take a gist of what is interprocess communication. So multiprogramming ma jab धेरै processes are executing simultaneously, some of them need to communicate with each other. So when they communicate, it is known as interprocess communication. Now two processes can communicate with each other by two methods. One is called the shared memory, the other is called a message. The name suggests message passing बनेको, this first diagram if you see. So how does two processes communicate? They are in the memory. So process A communicates with process B. Not they communicate via a queue of messages. There is a queue, and all messages are stored in this queue. It is in the kernel. So process A will send his message here, and again process B will read his message from here. So obviously you will need certain system calls to achieve this. So process A would probably signal a command called send system call. So once he initiates a send command, then he can send the message. And process B, whenever he wants to read, he will initiate a read command, and he will read from the queue. So it's like an asynchronous kind of message passing, client server message passing. A more analogous example can be when we send an email to your friends. Now Now, on the other hand, a shared memory and two processes, A and B, want to talk to each other, but they're doing it directly. They're not putting kernel in the middle. So if process A wants to talk to process A, shares his memory with process B. Now process A, whatever he wants to tell process B, he will write it in this memory. Process B, whatever he wants to read or write, he will write it in this memory. So both of them are sharing this memory. So communicating processes can communicate via shared memory approach or message pass. So again, the problem lies with the shared memory. So just imagine sharing the same data. That is fine. So you are reading multiple processes at the same time. So at the same time, many processes are writing and reading in the same process. So there could be a wrong read. Someone could read it wrong. Someone could write it wrong. So all of these errors can happen. Unexpected errors can happen. So that is why we need some kind of synchronization when it processes that communicate, especially when they're communicating via some kind of shared memory. When they're sharing a memory or sharing a data. So when they're trying to do that, then when they're reading and writing, all of them are reading and writing in the same place, there tends to be a lot of problems, and we'll see what problems that arise. And so that is a place where we need to concentrate. Now, why single processor system or whether it's a multiprocessor system, it is called concurrency. Now, to give you an example of what concurrency means, here you've got a single processor, and what do I mean? So you've got many people. So these are all processes, and there's only one person who's making this coffee. He's just got a coffee. So all these are tasks. So multitasking. He's multitasking, and when he can take order from one guy, and he can start doing one task, or order from another guy and starts doing another task. So this guy is one processor, and he's starting multiple processes. So it's kind of same time he's trying to address. One person is trying to address many people. So concurrency is single process system. Now take for example concurrency is multiprocessor system. If instead of having one guy, you've got two guys, so there's a multiprocessor, and you're handling concurrent at the same time many people. So this is a very nice example where you can see concurrency in single processor and concurrency in multiprocessor. Here, since this guy is executing with this processor, this guy is executing with this processor, they are executing in parallel. So this is parallel processing, and there are two processors simultaneously doing two jobs. Here there is only one processor, but it still looks like both of them are executing at the same time, even though there is only one processor. So this is some way a pseudo parallelism. Now both these single processor and multiprocessor system tend to have certain problems, inherent problems. So one is these are the three inherent problems that concurrency tends to have whenever there is a system, and that system has some kind of many things happening at the same time. So one is optimal management of resource allocation. So what is the primary job of an operating system? Operating system allocate resources like CPU, memory, input, output, files. All of these resources it must allocate in an optimal manner to all the requests, to all the processes that need it. It must assign these resources optimally to them. Now the problem arises when is that these resources are finite, means they are not infinite. So if they are exhaustive, they finish. So maybe there are 100 processes, but you've got only 3 resources. So how do you share these 3 resources within those 100 processes in a very efficient manner? When many people are asking for the same thing at the same time, then it becomes a problem. When there is concurrency involved, then resource allocation and management in an optimal manner becomes a problem. For example, there is a process, say P1, and he requests for input output, and the input output is granted to him. As soon as the input output is granted to him, so he's got hold of this input output. So as soon as the input output is granted to him, this P1 is suspended. So then what happens? No other process can use this input output because this input output was granted to this guy. So the resource allocation was somehow not optimal. Or another scenario you can take is the process P requests for input output, and he gets the permission for input output. But he can do input output only if he gets another resource, and that resource is not free. So he waits for that not free resource. He keeps waiting, all the while holding this input output. He's making this input output busy. even though he's not working on it. So he requests for input output and he gets the input output, but in order to finish his requirement, he needs another resource which is not free just now. So he's waiting for the another resource as all the while holding this resource. So this resource is underutilized. So these could lead to problems like deadlock. That is where we will see in the last chapter how we how we address these issues. Another issue because of concurrency, multiple processes running at the same time. And the another problem that is inherent is locating programming errors. So since there are concurrent processes running at the same time, finding those errors, especially logical errors, and recreating the context in which the error occurred. Kosto environment the error bhako थियो. So in order to investigate and find that error, it becomes really difficult. Okay, that's one problem. And like I said, the third problem in concurrency is many concurrent processes share variables and data. They'll be working on the same data or the same file, or they'll be working on the same memory section. Then there lies a lot of problems. Fine. Now concurrency गर्दा multiprogramming गर्दा concurrency गर्नु पर्यो हैन. concurrency गर्दा धेरै problems आउँदो रहेछ. त problems आउँदा operating system ले के गर्नु पर्ने रहेछ, operating system को के कसरी headache हुँदो रहेछ भन्दा operating system so many processes are entering the system and exiting the system, new processes are coming in, old processes are dying out. So he needs to keep track of all these processes. So this is something we've already done. He does this with something known as a program control block. An entry into the program control block. A program control block looks something like this. We've already seen every process that is created, all of its information is kept by the operating system. So every time a process is created, all the process number, the process counter, the registers, the memory limits, the list of open files, the list of all of those communicating, all the list of all the child processes. So all of the information is kept. So operating system ko first concern was to keep track of all the processes. He does that by PCB. Fine. Now he needs to protect data. So when one process is working with a data, operating system must not allow another process to interfere and spoil that data. So he needs to protect that data. So P1 is working on a data. P2 cannot interfere when P1 is working in that data. That onus lies with the operating system. The operating system must make sure that when P1 is working with his data or any other resource, when he has a resource, nobody else will interfere when he's using that resource. So that boils down to what is synchronization. So this is what we're going to see in this unit. Synchronize. How does the operating system, try and protect this data? How does the operating system try and not let others interfere? One process does not interfere in another process. So one example is here. This is a diagram I've shown. Is so how can you synchronize many processes that are sharing the same data? How do you protect that data? Many processes want to access the same data. So when one process is working, the other process should wait. When the other process is working, the third process should wait. So this is some kind of synchronization. So how can you achieve synchronization? We can view synchronization as this room. This is a room. This is a common room. This is a shared data. So if a process finds the door to that room open, this is the data room, he enters and he locks it. Now the door is locked. So if a new process wants to come into the data, he finds it locked, he waits. Now the old process that is inside the room, once he finishes reading and writing the data, he comes out of the room and leaves the room unlocked. So the new process, the second process wants to come in, he finds the room open, unlocked, then he goes inside, he locks it. So some kind of locking system must be there to prevent another process from interfering in another process's work. Right? So there are two kinds of synchronization basically. One is called the control synchronization for coordinating certain actions. So sometimes process A has to execute before process B, because process A will compute a result and give it to process B. Process B will take the result from process A. So process A has to execute before process B. Sometimes that coordination is required. So for such coordination, we've got so that coordination भनेको synchronization हो. So त्यस्तोलाई हामीले control synchronization भन्छ. अनि कोही बेला प्रोसेस धेरै प्रोसेसेसले त्यही डेटा शेयर गर्दै गरेको हुन्छ अनि त्यो डेटा शेयर गर्दा कसैले कसैको डेटा पढ्ला, कसैले रङ डेटा राइट गर्ला, कसैले रङ डेटा रिड गर्ला, त्यति बेला सम काइन्ड अफ सिङ्क्रोनाइजेसन इज निडेड, समथिङ लाइक दिस डोर. त्यो हुनाले त्यस्तो सिङ्क्रोनाइजेसन नामले के भन्छ, डेटा एक्सेस सिङ्क्रोनाइजेसन. सो देयर इज अ भेरी special case called race conditions. So when 2 or 3 processes are accessing the same data, say this is a common data and many processes are accessing the same data, then there can be a lot of unexpected results. There could be errors. So that error is called your race condition. So the third concern of the operating system is how to handle optimal resource allocation. So you've got very limited resources like R1 and R2, you've got only 2 resources and many processes can request for the same resource. So how do you handle them optimally, so that there is no deadlock? See, so if P is requesting R, so R must be given to P. So this is fine. But if you see this scenario, there is resource 1 and resource 2. Now resource 1 is given to P1. P1 has resource 1, but P1 also needs resource 2. P1 has resource 1, but P1 needs resource 2. But resource 2 is, who's got resource 2? P2 has got resource 2. Now P2 has resource 2, but P2 needs resource 1. But resource 1 is with process 1. So process 1 has resource 1. Process 2 has resource 2. Now in order to finish process 2, he needs resource 1. In order to finish process 1, he needs resource 2. So it's in a circular loop. It's an infinite loop. No, it's a deadlock. So such must be avoided. That is another headache for operating system. So that we'll see in the last unit. So now, for now, we're going to see how to protect data when one process is using it, so that another process does not interfere and spoil the data, and you have unexpected results. So such unexpected results are called race conditions. So the process of protecting such data from interference from other processes is called synchronization. There are 2 kinds of synchronization: control synchronization for coordinating actions, who goes first, and data access synchronization is to avoid race condition. First one here, data synchronization. So data access synchronization. So when synchronization happen, data access synchronization happens when 2 or more processes are the same data. So, and the result of the execution when they're sharing the same data and the order ma tyo execution bhayo, that also depends. So if the result depends on the execution, so say there is a shared data, say there is a common room अनि यो रुममा एक जनाको त जाँदैछ, त ए पहिला गयो, त्यहाँदेखि बी पहिला गयो, त्यहाँदेखि सी पहिला गयो, एउटा रिजल्ट हुने, सी पहिला गयो, बी त्यहाँदेखि गयो, ए पहिला गयो, त्यहाँ अर्को रिजल्ट हुने. त अर्डर अफ एक्जिक्युसन कुन चाहिँ प्रोसेस पहिला त्यो डेटासित वर्क गर्छ, which process is working with the data first, the order. If one order gives one result, the order gives another result, then that is called a race condition. भनेको ए पहिला गयो, ए जाँदा बी गयो, बी नसकिकन सी गयो, अर्को रिजल्ट भयो, सी जाँदै थियो, सी जाँदा बी गयो, त्यहाँदेखि ए गयो, त्यो हुँदा अर्को रिजल्ट, त्यो अर्कै अर्डरमा अर्को रिजल्ट आयो भने then it is called a race condition. So race conditions provide unexpected results. So it's a bug. So let's see how. I've got an example here. We're going to see an example. Say the first example we take is of this sharing data problem of a bank. Let us imagine that there are lots of ATM machines A, B, and C, and all of these ATM machines can read and write to the same. So this is account 1, account 2, account 3. So all of these ATMs can write to account 1, all of these ATMs can write to account 2, and so on and so forth. So these accounts become shared data. These becomes processes. Let's see what happens. Now let's take a scenario for deposit. Let's take the example deposit. All ATMs are depositing. So when you deposit, when A deposits, say we are only depositing to one account. So if A deposits to the first account 1, so and B also deposits to the account 1. Let's see the different scenarios. Deposit function कसरी चल्दो रहेछ. So deposit गर्नुभन्दा अगाडि त्यो ATM ले first balance get balance गर्नुपर्दो रहेछ. The balance suppose 0 थियो. He gets balance 0. He reads 0. Fine. This is a shared variable. Balance is a shared variable. Everybody is sharing this balance. Then balance मतलब गएर हेर्छ कति रहेछ 0 रहेछ भन्छ. Then यो उले deposit गर्दा add 1 गर्दा हुन्छ. Add 1 गरे पनि 0 plus 1 कति भयो 1 भयो. So he writes this result back and balance becomes 1. So this is a deposit function. And let us just take this deposit function and see A also depositing to the same account, B also depositing to the same account. Case 1. Now he looks for the balance. He gets the balance. Okay, that account has balance 0, fine. Then the A ATM says, okay, add 1. He adds a 1 rupee and he adds 1 to the balance. Usle padeko balance 0. So 0 ma 1 add huncha 1 huncha, and he writes it back to the result balance equals to 1. So balance equals to 1 goes back to account 1 and balance becomes 1. After some time, ATM B, he says, please get the balance. Now the balance reads 1. So whatever he reads, he adds 1 to what he reads and he writes back result 2. It is fine. A added 1, 0 balance but a 1, it became 1. B added 1, 1 already थियो, 2 भयो, it's perfectly fine. What if it ran something in case 2? A gets the balance is 0. At the same time, after some time, B also reads the balance and balance is 0. So both of them have their balance, his balance variable reads 0, his balance variable equals to 0. Now A says, okay, please add 1 to my balance variable. So he adds 1 to his balance variable. The balance variable A is 0. So 0 plus 1 is 1. Then B also adds 1 to his balance variable. Balance variable in B also he read is 0. So he adds 1 is to 1, 0 is 1. Now A, after that A, suppose thing he writes back and balance becomes 1. He writes back to the account. Yeah, balance is 1. After some time, B also writes back whatever he's added and he's also added 0 more 1. He also writes back 1. So even though A deposited 1 rupees, B also deposited 1 rupees, the final balance account in account 1 is 1. So there is an unexpected result. So because the order of this execution, who executes first, if this whole complete executes, then there's no error. But if he executes, then he executes, and again he executes, he reads, then he reads, then he writes, then he writes, then he writes, then he writes. So all of these things are happening. Then there is an unexpected result. Such a case is called a race around condition, when the order of the execution will change the result. That's called race around condition. When two or more processes are sharing the same data and the order of the execution also affects the result, then it is called race around condition. So race around condition नगर्न लागि के गर्नुपर्छ? अघि सिंक्रोनाइजेसन भनिहाले, एउटा एकजनाले डेटा पढ्दा अर्कोको लागि दैलो बन्द हुनु पर्यो हैन? त तपाईले डेटा पढ्न लागि दैलो खुल्ला हुनु पर्यो, तपाई भित्र गएर डेटा पढ्छ अनि दैलो बन्द गर्छ. नयाँ मान्छे आयो भने दैलो बन्द हुन्छ. You will not go until unless you don't finish, the other person cannot go. So that is one way you can do that. And when you do that, when only one process can work on the shared variable and other person cannot come and interfere, that is called mutual exclusion. So mutual exclusion गर्यो भने race around condition हुँदैन. So it is a concurrency control property which is introduced to prevent race condition. So race mutual exclusion भने के हो? Only one process at a time will manipulate the shared data. Right? So what is an answer to race condition is mutual exclusion. So भनेपछि mutual exclusion एउटा property हो जुन चाहिँले चाहिँ हामीले data access लाई synchronize गर्न सक्छ. ओके, data access synchronization गर्न लागि एउटा चीज हुनु पर्यो. त्यो चीज के हो? mutual exclusion. Mutual exclusion भनेको one process will manipulate data only at one time. Okay, only one person can manipulate at one time. And त्यसो गर्दा हामीले यो सबै unexpected errors such as race around conditions लाई avoid गर्न सक्छ. Now let's come. Now finish data access synchronization. Like here there are two kinds of data access and control. Data access भनेको mutual exclusion ले race around condition avoid गर्यो. Let us see control synchronization. Now control synchronization can be implemented using precedence graphs. The precedence graphs भनेको के हो भन्दा, it is a directed graph such as this. Now the directed graph means there's a graph that has nodes and edges and it has certain direction. And the directed graph can be represented by G of NE, where N is the node and E is the edges. The nodes can be the concurrent processes, or the nodes also can also resemble different parts of the same program. Okay, maybe a program is having different parts and all of them are running concurrently. So in that case, all the subparts of the program that are running concurrently will be resembled by N. In case you want to go a little coarser, that is granular level. If you want to go a little coarser, a little higher, then a little more general, then n can also represent different processes. For our example here, we've got the same program but different statements. So here you got different tasks. Fine. Now precedence graph ले के गर्छ भने हामीलाई certain order दिन्छ. So control synchronization भनेकै coordination हो. Should A go before B or should B go before C? So now if you look at this, PI, process I precedes PJ. When does this happen? Here भनेको चाहिँ process J cannot execute before process I. Okay, so process J cannot execute before process I. भने process I पहिला execute हुनै पर्यो, त्यसको बादमा मात्र process J execute हुन्छ. त्यसो त्यो हुनाले PI precedes PJ हुन्छ. So now let us look at this program. There are 6 statements. Now if you can see, X is A minus B and Y is A plus B. So they are somehow sharing this variable, but and this is a sequential program statement, like a C program. Sequential भनेको one after the other, the control will go and read all the statements. That's called sequential programming, unlike event-driven programming languages. So these are linear sequential programming language. This is a linear sequential programming language. So S1 will execute first, S2, S3, S4, S5, S6. So it will execute. If you see statement 1, first he'll execute. So A and B variable must be ready. It's already populated, so he can execute. Statement 2, A plus B. So statement 2 does not depend on statement 1. A is some shared variable, so X let me H along, so Y let me H. So these two can run concurrently, fine. X, to get the value in X, he doesn't have to wait for anybody. A is available, B is available as a global variable. To get the value of Y, A is available, 1 is a constant, so he also doesn't have to wait. Look at Z. To execute Z, you need X minus Y. So until unless X is not computed, Z cannot compute. Until unless Y is not computed, S2 is not computed, S2 will give you Y, Z cannot, S3 cannot be computed. Similarly, S4, statement 4 is dependent on Z. Z means statement 3. So statement 4 is dependent on statement 3. So statement 4 can only execute after statement 3 executes. Statement 3 can only execute after statement 1 and statement 2 execute. So that means S1 and S2 precedes S3, S4, S5 and S6. So similarly and so forth. So here we've got the graph. So first we find, to draw a directed precedence graph, we must find those statements that can run concurrently. So in our case, S1 and S2 can run concurrently. We've written S1 and S2 here. Then S3, after it's a sequential programming. So S1 सकेर S2 execute हुन्छ, S2 सकेर S3. अब S3 execute हुनु लागि के हुनु पर्यो? X भनेको S1 बाट X निक्लिन्छ. So S1 पनि execute हुनु पर्ने छ अनि he needs Y also. So Y and S2 पनि सकेको हुनुपर्छ. So S2 पनि सकेको हुनुपर्छ, S1 पनि सकेको हुनुपर्छ, S2 पनि सकेको हुन्छ. Once both of them finish, then they will give you S3. Here you go, S3. Yeah, they will give you S3. And similarly S4 is when S1, S2, S3 and S4 finish, you get S4. So here you go, S1 also finish, S2 also finish, you get S3. When S3 also finish, you get S4. So S4 को लागि त Z चाहिन्छ, Z is S3 finishes. So similarly you find a graph and you finish the graph. Now this graph not only give, so what happens? What information do we get from this graph? We get that, look, your program लाई break गरे भने S1 र S2, statement 1 र statement 2 of the program can run concurrently. Both of them can go into the memory and then they can start using the CPU and the resources, and there's no problem. Okay, because there's no order they must follow. But S3 can start executing only provided S1 and S2 have finished execution. So somehow this graph tells you the order of activity. So this graph, with the help of this graph, we can have some kind of a controlled synchronization. And apart the order of activity, apart the information about the order of execution, they also tend to tell us the number of processes required to have the most efficient execution of this program. So in multiprocessor system, you must, how many processes would be required? If there are many processes, how many processes will be required to execute this program in the most efficient manner? So the number of processes, also somehow it tells you like the number of the cardinality of the two independent processes. Okay, so here S1 and S2, so there are two processes root ma. So you probably need, not you probably, you will need two processes to have the maximum highest execution rate, in a very efficient manner. So this is a precedence graph. So what have we studied so far? We've studied what is multiprogramming in very short. Multiprogramming गर्न लागि we need concurrency. Concurrency भनेको सबै processes at the same time execute हुनु हो, whether in a single processor or a multiprocessor. Single processor होस् या multiprocessor होस्, concurrency हुँदा certain problems हुन्छ. Problems कस्तो, resource allocation राम्ररी हुँदैन, shared data हुन्छ, त्यसमा problem आउँछ. त्यहाँदेखि so why do you need to synchronize? So जब shared data गर्छ, race around conditions हुन्छ, त्यो race around condition ले unexpected results दिन्छ, त्यसको लागि synchronization हुन जरुरी छ. So there are two kinds of synchronization, race around synchronization. Race around condition लाई हेर्ने synchronization र data access synchronization भन्छ, किनभने common, they are sharing the common access to the same data. अनि एउटा proper race around condition लाई mitigate अलिक कम्ती गर्छ, that is called mutual exclusion. अनि अर्को छ control synchronization, when the order of important A must go before B, B must go before C. So त्यसलाई control गर्नु control synchronization भन्छ. How can you achieve this? We can achieve this with precedence graph, which is a directed graph. Fine. So and today's last class we'll do is what is critical section. Now we said, now look, this is sharing the data. Okay, sharing data, not data. Now say person one has some program, and that program runs sequentially, and then he writes to some document, and person B also has some program, and that program is also writing to the same document. Now the program is of many lines. Even this program is of many lines. All the lines in the program do not write and read to the same file. There could be only a few lines that is reading from this file, or there could be only a few lines that is writing to this file, especially writing. So suppose 100 line को program छ अरे person A को, तो 100 line को program 100 line ले नै write गर्दैन, because के हुन्छ integer हुन्छ, definite के हुन्छ printf हुन्छ, scanf हुन्छ, त्यही write to a file चाहिँ एउटा दुईटा line, some small section of code हुन्छ. यहाँ पनि only a small section of code will write to the file. So in one big program, that section of the code that is responsible for writing to a shared document, यसको पनि ठुलो प्रोग्रामबाट जुन चाहिँ कोडले चाहिँ राइट गर्छ यो शेयर्ड डेटामा, that code is called your critical region. क्रिटिकल किनभने जब तपाईले राइट गर्नु थाल्छ डकुमेन्टमा, जब तपाईले राइट गर्नु थाल्छ अनि तपाईले अर्डर उले लेख्दा तपाईले ओभरराइट गरे भने, उले लेख्दा तपाईले ओभरराइट गरे भने अगेन रेस कन्डिसन हुन्छ. सो जुनै पनि प्रोग्राम छ त्यसको सबै लाइन अफ कोडले यो रेस कन्डिसन बनाउँदैन रहेछ, अनि सर्टेन लाइनले गर्छ. त्यो लाइन जुन चाहिँले राइट गर्छ यो शेयर्ड डकुमेन्टमा, यसको प्रोग्राममा ओन्ली दोज लाइन्स द्याट आर रिस्पोन्सिबल फर राइटिङ टु द शेयर्ड डकुमेन्ट. सो दोज लाइन्स द्याट आर रिस्पोन्सिबल फर राइटिङ टु द शेयर्ड डकुमेन्ट इज कॉल्ड योर critical region. So the portion of the code that accesses the shared data is called your critical region. Now it is very important to ensure mutual exclusion of critical region. अब mutual exclusion भनेको only one at a time हुन्छ हैन. सो यो क्रिटिकल रिजन भनेको हरेक प्रोग्रामको क्रिटिकल रिजन हुँदो रहेछ. सो प्रोग्रामको क्रिटिकल रिजन भनेको प्रोग्रामको त्यो लाइन अफ कोड द्याट इज राइटिङ टु द शेयर्ड डेटा हैन. त्यो क्रिटिकल रिजनमा चाहिँ म्युचुअल एक्सक्लुजन हुनु जरुरी रहेछ. सो व्हेन पर्सन ए इज इन इट्स क्रिटिकल रिजन भनेको के हो, त्यो लाइन अफ कोड द्याट इज राइटिङ टु दिस डेटा. जब यो प्रोग्राम इज इन द्याट लाइन क्रिटिकल रिजन द्याट इज गोइङ टु राइट टु दिस डकुमेन्ट, त्यसमा चाहिँ म्युचुअल एक्सक्लुजन भनेपछि पर्सन ए उसको क्रिटिकल रिजनमा छ भने नो अदर पर्सन क्यान बी इन इट्स क्रिटिकल रिजन. सो ओन्ली वान पर्सन क्यान बी इन देयर क्रिटिकल रिजन. इफ पर्सन ए इज इन अ क्रिटिकल रिजन, person B wants to grow into its critical region. Arco way of saying it, if person A is writing a file and even person B wants to write a file, then person B will have to wait. So only one person can write, or one person can be in the critical region. How? So maybe how mutual exclusion we can do? Maybe one way is whichever program wants to go into its critical section will tell, look, I'm going to a critical section, and he will update some variable. So he'll tell, look, I'm going to the critical section, and he'll wave a red flag, a variable that is called the entry section. As soon as he enters, he starts to execute his critical section. And when someone else wants to come to the enter his critical section, he sees, oh, this person A has already gone into his critical section because there's a red flag, so I cannot go. So when this person A finishes his critical section, he exits from his critical section, he removes the red flag, he removes the red flag, that's called the exit section, then another person can go. So you can have a do while loop where any code that reads or writes to the same file is called a critical section. So before you can before you can write to a file, shared file, before the program writes to a shared file, this critical section, before you can reach this critical section, you must do certain things. That's called an entry section. And after you finish executing a critical section, you must do certain things. That's called an exit section. So we will see how this critical section problem. So what is a critical section problem? So there is a critical region problem. So what is called a critical region problem? Critical region problem भनेको हरेक program को critical regions हुन्छ. So एउटा program must enter its critical region, and when one program is in its critical region, no other program process can be in its critical region. Only one process can be in its critical region at one time. So there must be a mutual exclusion for critical regions. So how do you achieve this mutual exclusion for critical regions? That is called your critical region problem. Fine. So we will continue this in the next class. For now, I will switch off. Okay, again tomorrow I'll come back and we'll continue the class for how to achieve these critical regions. Okay, thank you. I will see you tomorrow again, and bye.